Alright, hey guys, this is geometry for Tuesday, April 28th. And so this is a very big day. This is our last chapter, and this is also our trig chapter. And so trig is my favorite, it's my baby. It's what I love the most in college, it's what I enjoyed the most. And really it applies throughout calculus and all kind of different things. And so you really use these a lot as you go up through math. And so, like I said, this is the fun ones for me. This is probably, out of all the math I've done, probably the one I enjoy the most. And so hopefully y'all will get a little something out of this, and if nothing else, get really solid with our trig here. And so, basically I am on page 582. This is the introduction to trigonometric ratios. And so, essentially what happens is, for trig, for our problems that we did in the last chapter with triangles, we did basically, you could have any type of triangle. So you could have like any type of angles within the triangle. Trig mainly deals with just the right triangles. And so we deal with mainly just our right triangles. And so if you get the definition here, it's in the middle of page 582. It says, trigonometry is the name given to the field of mathematics that deals with triangles, their angles, and the ratios of their side measurements. The word trigonometry is derived from the Greek word trigonon, and metrica, it means triangle measure. So trigonometry is literally the study of triangle measurement. And so basically what happens is we have a couple different understandings of a triangle. And so if you look, I'm going to skip to, I'll skip some of that and we'll just go through it together. I'm basically on page 584 in the little chart that says trigonomic ratios. And so basically what happens is we're going to have some type of right triangle. Okay, it doesn't really matter what the angles are for right now on the outside of the right angle, but it's a triangle nonetheless, a right triangle. Now, if I have an angle in the triangle, I'm going to just name it angle A. We'll do this angle A right here. Okay, we basically have three different types of trigonomic ratios. There's actually 6. Their inverses count 2. We're only going to do 3 for us. And so we're going to do 3 different types of ratios. The first type is the sine of A. And so the sine of A basically is going to look at the triangle, and it's going to compare the opposite side of A, of angle A, over the hypotenuse. And so the sine of A is written sine of angle A is written sine, and then with the A, and it's the opposite over the hypotenuse. So if you look at the triangle I have on the board, I put angle A up at the top. So the sine of A would be where we put the actual opposite side of A over the hypotenuse. And so if you do the opposite side over the hypotenuse, then that will help us out. And so if I do that right here, it would be the opposite. That will say that's A, that's side B, and that's side C. And so it's the opposite over the hypotenuse is the C. So it would be A over C. Opposite over the hypotenuse. Now cosine of A is adjacent over the hypotenuse. And so opposite is literally the opposite side directly across from the angle. The adjacent side is the side that actually connects to the angle that you're looking at. And that's of course not the hypotenuse. Hypotenuse is always opposite of the right triangle. And so the adjacent side of angle A here would be this B. And then the hypotenuse would be C. And so it's generally written B over C. The adjacent side over the hypotenuse. And then the tangent is opposite over adjacent. And so the tangent is just the opposite. So the opposite of A would be A over the adjacent, which is B. And so those are the 3 ratios. You need to understand that. You need to have that memorized. The A over C, B over C, A over B part, not so much, but you need to understand what you're actually dealing with. So sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and the tangent is always opposite over adjacent. So again, you just need to have those kind of get into your mind. Now, if you look, what we're going to do is I'm just going to kind of do this again with you real quickly. So I did my A, B, and C here. So again, if I'm looking at this angle, I'm looking at that angle right there. That's my angle that I'm looking at. if I wanted to know the sine of that angle based on what I wrote up here, then the sine of this angle, if I'm looking at this angle, the sine of it would be opposite over hypotenuse. And so you would do opposite over hypotenuse. And so for that, you would have sine of A would equal A over C. Okay, same principle. If I were to do the cosine of A, cosine of A is adjacent over hypotenuse, and so adjacent is basically the leg that connects your angle and your right angle, and so B would be my adjacent to that angle, and so it would be B over the hypotenuse, which would be B over C for this one. And then tangent, of course, is our opposite over adjacent, and so it will be A over B for this one. So again, opposite was A, adjacent was B. So now look at the bottom triangle. That basically just redid what I did over here. Now the next problem here is I'm actually going to throw in some numbers in there. And so the key here is it does depend on what angle you're using. So notice here up on the board, I have this triangle, and notice you have two acute angles. You're always going to have a right angle, and then you're going to have two acute angles. And so these are always going to go from the angle you're actually referencing. The angle you're referencing is going to dictate what's opposite and what's adjacent. So basically, A and B, opposite and adjacent there, is going to be dictated by what angle you're looking at. And so if we're looking down here, I'll say the first time I go through, I will name this angle A. So I will name this one angle A right here. And so I'm going to be looking at that angle right there. And so basically I'm going to do the sine, cosine, and tangent for that angle right there. And so I would do the sine of A equals, and so sine of A is opposite over hypotenuse. And so I'm going to do the leg opposite of A, so that would be the 5. The 5 would be opposite of A, opposite, so that would be 5 over, and then the hypotenuse is always opposite of the right angle. So I would do 5 over 10. So sine of A would be 5 over 10. Okay, now I will do cosine of A. Okay, cosine of A is adjacent over hypotenuse. So adjacent is the leg that connects the angle I'm looking at back to the right angle. And so the A back to the right angle would be this side, that's a 6. That's the adjacent one. And so cosine of A would be 6. Hypotenuse would be 10. So it would be 6 over 10. And then tangent is opposite over adjacent. And so you're going to do the opposite, which was 5 over 6, which was the adjacent. So 5 over 6 should be the tangent for the one on the board. Okay, so that was dealing with angle A. Like I said, for every triangle, you're going to have two angles that you can do this with. And so I can also do this same triangle, but do it from angle B. So I'm going to do it from angle B and go through and do the same 3 again. So notice now I'm going to do the sine. Sine of angle B would be opposite over adjacent. So opposite of B would be 6 now. And then opposite over hypotenuse is the sine. So it would be opposite is 6. 10 would be the hypotenuse. So it would be the sine of B equals 6 over 10. So opposite, 6, hypotenuse, 10. Sine opposite over hypotenuse. So the cosine of B would be the adjacent over the hypotenuse. Notice the adjacent connects from the right angle to the angle we're looking at. So the adjacent would be 5, and then the hypotenuse would still be 10, so it would be 5 over 10. And then the tangent would be opposite over adjacent, so it would be 6 over 5. Okay, so real quick, those are the two, for that triangle, those are the 6 trigonometric functions that would be possible. 3 for the A angle, and then 3 for the B angle. So what I want you to do real quick is look at them and kind of see what you can tell based on the answers. Notice sine of A was 5 over 10. Sine of B was 6 over 10. Cosine of A was 6 over 10. Cosine of B was 5 over 10. Then the tangent was 5 over 6 for A, and then for B it was 6 over 5. So what I need you to notice, just kind of to keep in mind, notice that the sine of A and the cosine of B are the same. So the sine of A and the cosine of B are the same. And then you have the sine of B and the cosine of A are the same. And so basically the sine for one is going to match the cosine for the other angle. So the sine of A will match the cosine of B. And then the cosine of the sine of B would match the cosine of A. And then notice the tangents are just reciprocals. Tangent was 5 over 6, tangent was 6 over 5. So that will always happen for every one of them. You'll always have two angles that you could possibly do with it, and basically it's always going to be the same process. And so the sine and cosine for those two angles will always match, and then the cosine and sine for the two angles will always match. And so that's just kind of to keep you in check. That's a good way to just kind of check as you go to make sure you're doing it right. And so that is the basic process there. I'll look at a couple, they'll ask you these a couple different ways. They can give you the actual triangle, like I did here, and then ask you to go through and do it. They could also give you one like number 7. This is 7 in your book. So 1 through basically 6 there deal exactly like what I was just doing. They'll give you either the sine of A or cosine of B, and then you'll basically go through and actually give me whatever they're asking you for. So like for number 1, they say the cosine of A, so you would go to angle A, and then the cosine is adjacent over hypotenuse, so you would put the adjacent over the hypotenuse. And they're going to simplify the radical. If you don't simplify the radical, that's fine. I just need to make sure you get it set up correctly. Remember, radicals ain't supposed to go on the bottom. So if they are, you're supposed to rationalize it, but if we don't do that for us right now, that's fine. I'm not concentrating on that. I'm concentrating on getting them set up. So that's how you would do 1 through 6. Number 7, they say sketch a right triangle that has the given trigonomic ratio. And so basically they say for number 7, they just give you the cosine of A equals 2 over 5. And so you would just have to draw that. And so first off, you just need to know, okay, what does cosine mean? Cosine means adjacent over hypotenuse. And so the 2 would be the adjacent, and then the 5 would be the hypotenuse. And again, where you label it on the thing really doesn't matter. It just depends on where you mark your angle. And so if I mark my angle A here, then that's just going to dictate where I put the 2 and 5. So wherever you label the A is going to dictate where your opposite adjacent, all that is. So if I label my A here, then my adjacent would be here, 2 would be there, and then the hypotenuse would be 5. So that would be one way to do it. The other way you could have done it was if you named your angle A up top, then your adjacent would have been 2, and then your hypotenuse would have been 5. So either one of those would be correct. Those would be what you're doing. It depends on where you mark your angle, again, would dictate then what becomes adjacent and what becomes opposite. And so that would be number 7. So those would be like 8, 9, and 10 would work that way. 11 through 14, you're just basically giving all 3 of them. So they'll give you the triangle, and it says find the sine, cosine, and tangent of each acute angle. So you need to do it for each of them. You need to do the A and the B. So you have to set up for both of these angles and give me all the sine and cosine. So those will work exactly like I did on this one up on the board. So just start with your A, list all of them, the sine, cosine, and tangent, then do your B, list all of them. Remember that your cosine for one and your sine for the other should match, and your sine for one and your cosine for the other should match. So that should always work. So next I have 16 up on the board. Basically it says in each problem below, a trigonomic ratio for a certain angle in right triangle ABC is given. Find the other 2 trigonomic ratios for the angle. And so it may help to kind of sketch these. So 16, they give you the tangent of B. So the tangent of B. And so they give us tangent of B would be opposite over adjacent. So that would be what tangent of B represents. So when I'm doing my triangle, just thinking about it, I would have, if I do B here, then I would have the 4 would be opposite, the 5 would be there. And so basically I need to figure out what sine of B is. Basically, I need to figure out what sine of b is, and then I need to finish what cosine of b is. So sine of b would be the opposite over the hypotenuse. So it would be opposite is 4. So sine of b equals 4 over the hypotenuse. I don't know what the hypotenuse is. They didn't give that to me. So how do I find it? How would I find the hypotenuse? Well, it's a right triangle, so we're going to use the Pythagorean theorem. So to find what this hypotenuse is, I would just do 5 squared plus 4 squared equals whatever that is squared. So 5 squared would be 25 plus 16. 25 plus 16 would be what? 30, 36, 42, 41. So 41 would equal c squared. Then I'm going to take the square root and I can just do the square root of 41. So I know that my hypotenuse would be the square root of 41. So then when I do the sine of b, it'd be b over the square root of 41. And then when I do cosine, it would be adjacent, which was 5 over the square root of 41. Basically, if you have a missing side, we just use the Pythagorean theorem. And we could try to rationalize this if we wanted to kind of clean it up a little bit. But outside of that, that would be how you do it. So they wanted on 20, they wanted just the sine. So it would just be the 4 over the square root of 41, and then you would rationalize it. And so that is basically how you're going to do that. 19 through 22, again, you may want to do exactly what I just did. Draw the triangle, figure out what you have, what you're missing, and then you can use the Pythagorean theorem to figure out what you're missing and then find the missing one. And so that's pretty much the lesson. Again, the bulk of this, they can ask you the questions the different ways, but really the lesson is knowing that sine of A is opposite over adjacent, opposite over hypotenuse, cosine of A is adjacent over hypotenuse, and then tangent is opposite over adjacent. So tangent, opposite over adjacent, cosine adjacent over hypotenuse, and then sine is opposite over hypotenuse. So as long as you have that down, the rest of that should be okay. You're just asking me the question different ways. And so that will be today's lesson. If you have any questions, I'm more than welcome to get up with me and we'll go through it. So I hope you all have a good day.